Hello everyone, in this video we are moving on to our next topic. If you cast your mind back to before we started doing linear relationships, back when we were just on linear equations, we spent about a week on just solving linear equations. And all of those equations that we solved, it was just one equation with one variable, and we used a variety of techniques to solve it. The step up from that is the last topic that we're doing in this unit, and that is simultaneous equations, which is the situation where instead of having one linear equation with one variable, I've got two linear equations with two variables, and I can solve them both together. So we'll show you an example. I'll show you an example just to tell you what I mean. Let's say I've got the equation 2x plus y equals 5, and that was equation number 1. Now if I just gave you that, you couldn't do much with it in terms of solving for x and y, because there's no one value that x and y can be. This would be what we call a linear relationship, as we've been discussing over the last couple of weeks, and there could be a whole host of answers. X and y could take really infinite many values, and there'd be a lot of options for what we could make x and y to make this equation true. But if we have a second equation, let's say we also know that 3x plus y equals 6, and that was equation 2. And we knew that these two equations were both true simultaneously at the same time. Then we could use them together at the same time to solve for x and y. That's why they're called simultaneous equations, because we're using them at the same time. Now there are a couple of different methods that we can use to solve simultaneous equations, and in this video I really want to just look at one. So this video we're looking at method 1, which is substitution. Substitution. Okay, what I'm going to do is I'm going to write down over here on the left side of the page the 4 steps that I'd like you to follow to solve simultaneous equations via substitution, and then as we do each one, I'll go through applying that step to these two equations I have here to show you how it works. Once we finish that, we're going to look at a real-life example of a worded problem, a scenario when this would actually come in handy, and see what we can do with that using these skills. So step 1, the first thing that I want you to do is to pick one of these two equations and isolate one of the variables. So we want to pick one equation and isolate one variable. Okay, so let's say we picked equation 1. We've got 2x plus y equals 5. We can rearrange that. Let's say we rearrange that by subtracting 2x from both sides. So that'll give us y equals 5 minus 2x. So this is equation 1 as well, because they're exactly the same thing, just rearranged. All I've done is I have isolated y. So I've isolated one variable. Step 2 is then to substitute that value, and that's why this is the substitution method, into the other equation. So now that I know that y equals 5 minus 2x, I can look at equation 2 again, and wherever I see a y, I'm going to substitute this value here, 5 minus 2x. So I'm going to rewrite equation 2, 3x plus, and now instead of writing plus y, I'm going to write plus 5 minus 2x, because I've established that 5 minus 2x is y. They are the same thing. So instead of y, I can just write 5 minus 2x, and it stays the same. It means the same thing, and that equals 6. Now you'll notice that what I've done here is I've created one equation, 3x plus 5 minus 2x equals 6, one linear equation that only has one variable. And so we can solve it. And that is indeed step 3. We're going to solve that equation to find out what the value of x is. So let's do this. The first thing I'm going to do is collect my x's. So I've got 3x minus 2x, that equals 1x, or just x. So I get x plus 5 equals 6, which means that x equals 6 minus 5, which is 1. So I get my first result, that x equals 1. Now I need to do the last step of this substitution method, step 4, and this last step is going to help me find y now that I have x. So what I want to do for step 4 is I want to substitute again. So there's 2 substitutions happening in this method. I want to substitute again to solve for the other variable. So now that I know x equals 1, I can put that value of 1 back into my original equation, and it doesn't really matter which equation I put it into. I could put x equals 1 into equation 1 or into equation 2 and I'll still get the answer. For now I'll just do equation 2. So I have my equation, which is 3x plus y equals 6. Whenever I see an x, I'm going to put a 1 instead. So I get 3 times 1 plus y equals 6. And now you'll see that again I have a linear equation with just one variable, so I can solve that. So 3 times 1 is 3, and I subtract 3 from both sides to get that y equals 3. And there we go, we've solved the 2 equations simultaneously. We found that x equals 1 and y equals 3. Now I can double check my answer by putting these values into equation 1 now and seeing if it works. So if x is 1 and y is 3, does it equal 5? 2 times 1 is 2, plus 3 equals 5. So yes, I haven't made a mistake. Y is 3 and x is 1. Before we finish this video, I just want to do an example of a worded problem. So let's say we've got this question here. An event organizer wants to sell 100 tickets to an event and aims to make $1,400. If standard tickets are $10 and premium tickets are $20, how many of each should be sold? So if you think back, and if you can't remember how to do this, go back and watch the video on it. The first thing we need to do when we get these worded problems is to assign variables. So I'm going to make standard tickets S and premium tickets P. Then we need to pull the information out of the question to write some equations. So the first thing I know is that in total there are 100 tickets. So that means the total number of S standard tickets plus the total number of P premium tickets equals 100. And that's my first equation, equation 1. Next, I know that altogether I need $1,400. So if I do 10S, that's the total amount of money I'm going to make from all the standard tickets. And 20p is the total amount of money I'm going to make from all the premium tickets. And that has to equal 1,400. And that is equation 2. Now I can use my substitution method to solve these. So the first thing I want to do is I want to pick an equation and isolate a variable. So let's pick equation 1, and let's say if s plus p is 100, then p equals 100 minus s. I can now substitute that into equation 2. So 10s plus 20, and now instead of p, I'm going to write 100 minus s equals 1,400. And now I can solve this because it's just a linear equation with one variable. I'm going to do that by expanding the brackets first. And then I can solve. So 10s minus 20s is negative 10s, and that should be a 2,000. And then 1,400 minus 2,000 is negative 600. So s equals negative 600 divided by negative 10, which is 60. I can then substitute that value for 60 back into my original equation. So s plus p is 100. So if s is 60, then p must equal 40. and I can use my substitution method to say that I should sell 60 standard tickets and 40 premium tickets.